Linear inequalities are inequalities in two variables, and they're usually going to look a lot like the linear equations we're used to, but they'll have an inequality symbol instead of an equals symbol. So, just as a quick reminder, x is less than or equal to 5. When we graph that on the number line, we fill in the dot at 5 and then shade everything less than. If x is just less than 5, we have an open dot at 5 because we can get as close to 5 as you can possibly imagine, but we can't equal 5. We've also seen inequalities like this where we need to isolate x first, right? So we subtract and divide positive 16, goodness. And now notice when we divide by -3, don't forget what happens every time you're multiplying or dividing by a negative. We have to change the direction of the inequality. And I'm just going to leave this as a fraction. But when we graph this guy, 16 over -3, we're going to have a closed dot because it could be equal and it's greater. So we're going to shade this side. So our important reminders, or equal to, fill in dot, strictly less than or greater than, open dot. And when we are dividing or multiplying by a negative, we have to flip the sign. Let's look at solutions to inequalities. Remember, this is just testing whether or not this works or not. So we're going to take 2, put it in for x, and see if this makes this equation true. So 2 times 2 minus 5. Sorry, this inequality. It's not really equal at all, is it? 4 minus 5. Is it true that -1 is smaller than -3? Remember on your number line that smaller is on the left, bigger is on the right. -1 is not smaller than -3. It's to the right of -3, so it's bigger. So x equals 2 is not a solution for this one. Let's try for -1. 2 times -1 minus 5. Is that really less than -3? -2 minus 5, -7. Is -7 really smaller than -3? Yes. So we can test solutions even with inequalities in one variable, right? Let's translate that skill and do some with 2 variables. So now we have this inequality, 2x minus 5 is smaller than y. And we're going to say, is 410 a solution? That means when x is 4 and y is 10, is this true? Let's figure it out. 2 times 4 is 8. Is 3 smaller than 10? Yes, that works. Absolutely. Let's try 4, 3. 2 times 4 minus 5. I bet you can guess right now what's going to happen because you know what the left side is going to do. 8 minus 5. Is 3 less than 3? No. If this was an or equal to, this would totally work, but it's not. It has to be less than, and 3 is not smaller than itself. It's equal to itself. All right, one last one to test. 4, -1. We already know this is going to turn into 8 minus 5, which is going to turn into 3. Is 3 smaller than -1? No, it's not. So we found one solution that worked here when we were checking them, and 2 that did not work. Here's a similar equation. We're going to do the same thing, plug in our points, and see if they work for this given inequality, not equation. So -2 times 2 plus 3 times 3, is that greater than or equal to 3? This turns into -4 plus 9, which is 5. Is 5 greater than 3? Yes, that guy works. We're done. Amazing. Let's try this one. -2 times 4 plus 3 times 1. Notice every time I'm just putting in my number for x and my number for y. Is that indeed greater than or equal to 3? -8 plus 3 is -5. Is that greater than 3? Heck no. Does not work. Let's try 0 and 1. -2 times 0 is just 0. 3 times 1 is just 3. Is 3 greater than or equal to 3? Yes, this guy works because of the or equal to. That one's okay. All right, we found 2 points that work that time for a different inequality. So here we have a graph of an inequality, and what we want to do is see if these points are shown on this graph as solutions, they're in the shaded region, or not. So if they are not in the shaded region, they are not a solution. So let's look for -5, 2, and see if that is a solution to this inequality that's been graphed here. -5, +2. Yes, it's in the shaded area. So that is a solution to whatever inequality we have graphed here. I mean, I know what it is, but I haven't told you yet. How about 1, -4? Let's look at 1, -4. Oop, no, not in the shaded region. So that one is not a solution to this inequality. So let's go ahead and take a look and see what inequality this really is. Imagine for a moment that this is just a straight line, not a dotted line, and there's no shading on this graph. Could you write an equation for that linear function? I bet you could. Right down here is my y-intercept. And if I can find 2 nice points, I can find the slope, right? So about here and here. Is that down 5 over 3? So my equation for this, if it was just an equation, would be -5/3 x minus 5. So I would love to show you how we take this and turn it into the inequality graph that we actually have here. So since we don't really have that straight line, it was a dotted line. Remember how at the beginning we said that if x is greater than or equal to 5, we have a dot, a filled in dot. And if x is just greater than 5, we have an open dot. Really similar with linear inequalities. If we have a greater than or equal, we're going to have a solid line. And if we have just a greater than or less than, it'll be a dotted line. That tells us you can get as close to the line as you want, but you can't get right on it. So looking at this one, we have a dotted line. So that means it's not going to be or equal to. And then we're going to look and see, okay, well, is y greater than this or is y less than this? And the way we look at that is we see which way did it end up getting shaded. So looking at the y-axis, looking right on there, here's the line, and are the bigger y values shaded or the smaller y values shaded? So if the ones underneath are shaded, that's our less than. And that's what we have here. So y is less than -5/3 x minus 5. And we can't say or equal to because it has that dotted line. Let's do some more examples of just that. So let's use that same idea to write an equation for this inequality. We have a dotted line, so we know it's not going to be or equal to. We have 4 as my y-intercept. And what's our slope? Let's find another nice point. Here we go. Down 4 over 3 to the right 3. So that'll be 4/3 x plus 4. And now we're going to look right at that y-axis. Here's my line, my 4. Am I shading above it, greater, or am I shading below it, less than? In this graph, it's shading above. So we're going to say y is greater than 4/3 x plus 4. Not or equal to because it has the dotted line. Here we've got a solid line, y-intercept of 6. So let's put that in. What's our slope? Here's a nice point and here's a nice point. Up 2 over 1 to the right 1. So my slope is going to be 2 over 1 x plus 6. And now looking at the y-axis, Going from 6, are we shading above, bigger than 6, or are we shading below, less than 6? And this one we're shading below, so y is less than 2x plus 6. And since we had a solid line, that's an or equal to. Okay, using those same ideas, going backwards. Y is less than 2x plus 2. Let's start by just graphing it and come back to what our line is going to be in just a minute. Okay, so we're going to start at 2. And we're going to use the slope up 2 over 1. There's my 2 points that can make a line. Since this is not or equal to, it has to be a dotted line. Let's put in that dotted line, and then we're going to decide which way we or shade. So this says y is smaller than. So looking at the y-axis, we can't shade y is bigger. We have to shade y is smaller. So we're shading on this side. It's not my best shading, but... All right, here we've got y is less than or equal to our exact same equation. How nice. Starting at 2, up 2 over 1. Since it was or equal to, that's a solid line, just like it would have been a solid dot. And then y is less than, so we're going to shade below on the y-axis, shading here. All right, y is greater than, still my same equation, I'm just trying to make life easy, up 2 over 1. Since it's just strictly greater than, we need a dotted line. And then it is greater than, so on the y-axis, we're shading above. So we're shading up here. Okay. Greater than or equal to, same line again. That one, since it's or equal to, we get a solid line. And greater than, so we're shading above this on the y-axis. Okay. If your inequality is not in y equals mx plus b form, you can graph it using intercepts. You can put it into y equals mx plus b form. You can make a table and graph from 2 points on your table, however you want to do it. I am going to graph with intercepts today. How about? Because I can tell that if y was 0, x would be 2. And if x was 0, y would be -5. Ooh, danger, Dr. Robinson. All right, my x-intercept is 2 and my y-intercept is -5. Looking at my inequality sign, it's an or equals to, so we're going with a solid line. Okay. We've graphed it. Which side are we shading? Since we didn't put this into y is greater than or equal or less than or whatever to mx plus b first, it's a little bit harder to sneak it out, but we're going to find it. So here, when I was finding my x-intercept, this guy went to 0, I divided by 5, I had x is greater than 2. So I think I want to be shading over here. Let's double check with my other one though. I had 5x went away. I had -2y was greater than 10. When I divided by -2, which sorry, I did without saying anything, the sign switched, and now I have y is less than or equal to -5. So I want to shade underneath y. And hey, that's good. Those two are on the same side. Everything's looking good. I'm shading it that way. Let's do this whole thing, this exact same problem one more time, but using the mx plus b form. So gonna move this to the other side. Gonna divide by -2. Careful, careful. If we're dividing by a negative, the sign has to switch. Plus 5 over 2x. So I'm gonna start at -5. I'm gonna go up 5 over 2. Oh wow, it looks just like the one I had before. I'm gonna do a solid line. And then since this was y is less than, I'm gonna shade below on the y-axis. Fantastic, just like we had the first time we did it. Either method works, whatever works for your brain.